Hi, my name is Adam Vargas, and I'll be presenting on optical illusions. Optical illusions come in many shapes, forms, and sizes. Some of the most famous illusions include the checker shadow illusion, the herring illusion, and the Hermann grid illusion. But despite being famous, all optical illusions share the same goal: to mess with your mind. Optical illusions possess the ability to create an enjoyable experience to some, yet to others, that experience may be a mind-boggling and frustrating one. This unpleasantness may be due to the fact that an optical illusion is simply just an event that is tricking the eye and the brain. A prime example of an optical illusion would be the famous lilac chaser, also known as the Pac-Man illusion, created by Jeremy Hinton. This illusion consists of 12 blurred lilac-colored discs arranged in a circular formation surrounding a small cross, all in which are over a gray background. As described by New World Encyclopedia, each disc disappears briefly in clockwise order. When staring at the central cross, a viewer first sees a gap rotating around the circle, then a green disc that rotates around the circle, and finally, the disappearance of the lilac discs themselves. As the viewer watches an event occur and another event occur directly adjacent to the previous event on the same visual field, we tend to jump to conclusions and classify this action as movement. However, according to Richard Hume, this action is called apparent movement or beta movement because no true movement has taken place. If no movement has really taken place, then why does our brain trick us into thinking it really has? This false assumption of movement is caused by receptors in the brain that detect movement, called Reichart detectors. These Reichart detectors encode movement by detecting a change in luminance from within one part of the retina to the other. As stated by Hume, this is what causes us to initially see the short disappearances of the lilac discs. Stated by psychology expert Kendra Cherry as a second effect in the lilac illusion is the after image. An after image occurs when you still view the original image even though the original image is not present anymore. According to Hockenberry and Hockenberry, there are 4 colors that are divided into 2 pairs within this theory. These colors are red, green, and blue, yellow. Each pair of colors oppose one another. Thus, if one color is stimulated, say red, then the other color is inhibited, in this case green. Same for the other pair. If blue is stimulated, the yellow is inhibited, and vice versa. The after image that specifically occurs within the lilac chaser illusion is caused when a lilac stimulus that is presented to a particular region of the visual field for a long time disappears. A green after image will appear. The after image lasts only a short time and in this case is effaced by the reappearance of the lilac stimulus. The after image is a simple consequence of adaptation of the rods and cones of the retina. The final effect that aids in creating the lilac chaser illusion is known as Troxler's fading. Troxler's fading is explained in the New World Encyclopedia as occurring when a blurry stimulus is presented in an area of the visual field in which the viewer is not fixating on. In this case, the viewer is supposed to have their eyes fixed on the small cross located within the center of the 12 blurred lilac discs. Now, considering that the viewer has their eyes fixated on the cross, these blurred discs will eventually disappear, even though the discs are still physically there. Added by Richard Hume, the slight movement of our eyes in peripheral vision while fixating are still not large enough in order to shift these lilac discs to new neurons of the visual system. This then causes the after images to cancel out the original images of the lilac discs. Thus, all 12 blurred lilac discs disappear into the gray background. The illusion is now complete. What was once a gray background with 12 blurred lilac discs in a circular formation and a centered cross is no more. All that is left is a green spot continuously running around in a circular rotation with the gray background. Asserted by Hume, occasionally it seems as though the green afterimage has eaten up all the lilac discs. This accounts for the lilac chaser's illusion alternative name, the Pac-Man illusion, with all three effects corresponding in action with each other. This illusion is now successfully completed. As you can see, there is more to illusions than meets the eye, no pun intended. Different illusions involve different factors that take a role on the brain and eye, which are necessary in order to create their different effects. Illusions are not accidentally created by mishaps or coincidence. Illusions are scientifically created through careful studies on how certain images are viewed and portrayed by the structures within the eyes and the brain. Clearly, that is how Jeremy Hinton created the famous lilac chaser illusion, through a combination of the use of apparent movement and or beta movement, the use of the afterimage, and the use of Troxler's fading. He was able to create one of the most successful, mind-boggling illusions in the history of optical illusions. Thank you for listening to my project.